Okay.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. You're done?
Done. Hey everyone, hope you're still doing well. We are going to be going over another set of equations on gas laws. Today we're going to go over Gay-Lussac's laws. These will deal with pressure and temperature. We're going to keep volume at a constant. So I'll show you how to work through one of these. I'll also show you that wonderful little paint sample popsicle stick deal. Hopefully we stay in line with those. Just to show you where I'm at on the calendar, we are going over May 14th stuff. Hopefully you guys had a nice wellness day yesterday and everyone's all ready to go for today. Tomorrow you'll have practice with this, but if you want to do it today, obviously I share all of your work with you the Monday of each week. So just to get into this is what was shared with you. Again, let me put that equation up top. We're going to have pressure 1 divided by temperature 1 will be equal to pressure 2 divided by temperature 2. In this one, your pressures could be all over the board. They're going to be those 4 that you saw on that Boyle's worksheet. I can copy those over onto here as well. As long as they're the same, you don't need to worry about any pressure conversions. So let me just cruise through this real quick and make sure all of your pressures are the same. So far, so good. And yay. So it doesn't look like you need to do any pressure conversions. So yay for you guys. Everything will be good to go. Just know that you're not dealing with one pressure unit. You will be able to do all of these problems. So your pressure, as I was saying, will be any different label. It can be in atmospheres, kilopascals, millimeters of mercury, or I think there's one more and I'm just forgetting it. Yeah. Then your temperature you're going to want in Kelvin, just like we did on our last assignment. So make sure that if you're given a temperature in Celsius, you're adding 273 to that. So it's in Kelvin. So our first one says that we have a gas in a sealed container and it has a pressure of 125 kilopascals at a temperature of 30 degrees Celsius. If the pressure is increased, that's what you're going to do with your little sheet that you've made for PTV, to 201 kilopascal, what is the new temperature? So just to show you where I'm at over here, this is my equation I'm using. It tells me that my first pressure is 125 kilopascals and I have a temperature of 30, but that's in Celsius, so I want to add 273 to that. So it's not 30, it's 273. It's going to be 303 Kelvin. And that's going to be equal to 201 kilopascals over X. Same as before, you're going to cross multiply and divide. So I'm going to take 303 multiplied by 201 and then divide by 125. Cross multiply and divide. Times 201 divided by 125 is equal to 487.2 Kelvin. And just to kind of check to see if my answer makes any sense, in these problems our volume is constant. We're not doing anything with volume. And it said that our pressure is going to increase. So if I were to push this up, what is also happening to my temperature? It's also increasing. And so what I should see here is while my pressure increased, my temperature should increase. And what do you know, it did. Yay. So these shouldn't be too difficult. They should be kind of repetitive at this point. Your next sheet that we get into, we're going to squish all these together and we're going to learn how to do the ideal gas law. So hopefully this is making sense. You guys have about 10 problems to work through on your own. But as always, if you have any questions, please be emailing me. Sorry, I'm trying to shut my window. It's not happening.
Science.
You guys do some kind of fish thing.
Science. 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 Science.